First we look at graphical and tabular summary. If you go to the next slide, there is a data, and these data are for a component called plunger dial gauge. So this component goes into measurement tool, so it has to be very precise and very accurate, and one of the characteristic it should have is named as end shake, and specification is that it should be within 850 and plus minus 50. So if end shake is between 800 and 900, that is considered good. If it is not, obviously there could be rework or those items may get rejected, but both are expensive. Obviously rejected is more expensive, and if it can be salvaged by doing some rework, but still a company has to spend time and money on that. Initially, by looking at the data, you can see that there are many values which are more than 900. And in fact, you can also locate minimum is 837, maximum is 941. Basically, there is no problem in this data on the lower side because minimum is 837, so that is well within 800 and 900. So nothing is below 800. So that's not the problem. The real problem you can see is that there are many data points more than 900. So let's look at next slide. We have a tabular summary, and basically all the data has been grouped into different classes. So class midpoint is the midpoint of this group, and there is one data point in that group. There are 4 data points in the next group, and so on. So now you can see, looking at distribution of these frequencies, you can see that most of the values are concentrated somewhere around in these 3 groups between 883 and 918. Compared to the previous slide where you have raw data, this tabular summary is more informative because you can see what's going on slightly more clearly compared to that. You can also convert this information in the table in the form of a graph by creating a bar equal to these sizes for each group. You can get a histogram, as you can see, and you can also actually draw those lower specification limit, which is 800, and upper specification limit, which was like 900, and target is obviously midpoint, which is 850. This graph you can see becomes very informative compared to the raw data and even compared to the tabular summary. One thing you can notice is that most of the values are concentrated around this 900, the upper specification limit, and because of that half of the histogram is outside the upper limit. So all these items that are produced are all rejected, or they may need some kind of rework. You also see there is a lot of gap between this and this, so you may be very curious like why the histogram, like those people who are working on this process, why they are creating dimensions which are on the higher side, and there's a lot of leg room here. They could have even had this histogram slightly to the left, and that would have made many components within the upper specification limit without a problem. Looking at the histogram, one may be curious like why this is going on. One reason why people are staying away from this line and they are close to the other line, maybe this line is more dangerous. This line is more dangerous than the upper specification limit. Now by more dangerous I mean if the dimension is below 800, then those components may have to be scrapped, so total loss. Whereas this upper specification limit, if something is beyond that, you may still salvage those components by doing some rework. So it is less expensive if the items are beyond this, and it is more expensive if items are below the lower specification limit. It's like if you have some component and if you are doing a machining process, and suppose this width is of importance, and in this machining process you are taking out material from the top so that this width keeps on reducing till you achieve the dimension you want. If this width goes below something, it is very difficult to add more metal or material to this component and get it within the requirement. But if you are on the higher side, like if the width is slightly more than what you need, you can always carefully remove some more material or metal and get the desired width. So if it becomes less than what you need, so that will be total scrap. Whereas if you are slightly above the upper limit, you can still do some extra work and you can still use it. You can see like so much of information can be obtained by looking at a graphical summary. And that's the reason people say a picture speaks 1,000 words. So if somebody speaks at the rate of 50 words per minute, it will take 20 minutes to explain something. And especially, for example, if somebody shows you this data, so it will take a lot of time and a lot of discussion to figure out what's going on. If you show a histogram, then people can come to a conclusion very quickly. When you make a histogram, there are three things one should look at. One is location. Location means where most of the values are concentrated. Second one is spread. How much is the variation or spread in the data? So that's the second thing. And third one is shape. So these are the three things you should look for in a histogram. We have seen that the values are concentrated around 900. Spread is from here to here. So that's the amount of spread. And the shape looks like this. So it starts low, reaches a peak, and then again comes down. For different data set, you may get different type of patterns. So if it is symmetric, symmetric means, so if I have a shape like this, so symmetric means like these are called tails. This is a left tail and this is a right tail. So if these tails are approximately of same length, then you can say it is symmetric. And when it is symmetric, your mean, median, mode, those are same. You may also get a shape like this, and this is called skewed to the left because the tail goes on the left side. So this is the left tail. So left tail is longer than right tail. In fact, there is no right tail in this histogram. You might get this kind of pattern. Like one example I can give you is very easy exam where most of the students score very high, but some students who are not able to study for whatever reason or did not spend enough time or were not careful, so they may still score low grades on this easy test. So for easy test, generally you will see a histogram which is skewed to the left. It is also called negatively skewed. It is called negatively skewed because the tail goes on the negative side. So on a graph you have positive sides on the right side, on the left side you have negative values. So it is called negatively skewed. Now this is a positively skewed histogram. So one example where you can get this picture is tough test. So in a difficult test, most of the students will score low, but some students who spend more time studying may still score high grades. You can also get this skewed to the right if you have data on employee salaries for a company, big company. So most of the employees you will find make salaries in a certain range, but there could be some senior management, top management people who make millions of dollars. You can also get this pattern if you are looking at house prices in a given area. Most of the house prices will be at certain level, but there could be some houses again which are very, very expensive, maybe millions of dollars. So I gave you example of making a tabular and graphical summary when you have some data. So now let me also show you how to do this when you have Excel file. So how to summarize data in tables or graphs, because many times we have like a lot of data. For example, the file you have for your homework, contains thousands of data points. If you want to summarize this data, let's say we want to summarize this data for states. There is a very simple tool called PivotTable in Excel that will be very useful. Now to use PivotTable, start somewhere in the data. Your mouse or your cursor has to be somewhere in the data, it doesn't matter where. And then you want to insert PivotTable. Click on Insert, and the first thing you have is PivotTable. Dotted blinking lines indicate that all data is selected, and they are selected because we started from somewhere in the data. So we don't do anything, simply say OK. So as soon as we do that, you will have this template. So on the left side, you have an empty template which you can populate the way you like. On the right side, you will see that all the variables in that Excel file are listed. So you can choose any variable you are interested in. Now your table will be like this. So in the rows, we will have name of the state. So that will be the first column, and the second column will be how many cars have failed in each state. So let me drag this state and drop it here. So as soon as you do that, it pulls all the data from the data tab and populates this column with names of states. First one you can see is a star. Maybe for one of the claims, the person who was entering data forgot to enter state. So star means missing data. Now in this field we want values, so simply drag this and drop it here. So now you can see for every state how many failures occurred, that is indicated. One simple thing you can do is you can arrange these numbers from maximum to minimum. You should be able to arrange this data in ascending or descending order. So click anywhere and then simply say Z to A. So it can show you which are the top states with car failures. Now one more thing it can do is, like sometimes people want to solve problems, they want to dig deeper, they want to take a deep dive and understand what's going on. And let's say for Alaska, there were 4 car failures, and an engineer just wants to look at all the data only for Alaska, all those 4 failures. So just double click. What Excel does, out of those thousands of data points, it will pull out data for all the columns specific to that state. So that is very useful, and because you are able to do this very quickly. So what I did was started somewhere here and inserted a pivot table. At the bottom you can see these 2 boxes. There is a row label and values. So I can drag and drop this in rows and get the same effect, and drag and drop it here and do the same thing. Now let's say you want to do something with the top 5 states. So 1, 2, 3, 4, 5. So you can always copy them and put them somewhere else. And let's say you want to make a graph for these 5 states. So you can always insert a graph like this. Or if you're interested, you can also make a pie chart. So you can display percentage or numbers and things like that. Now let's say we want to analyze mileage. So mileage is a quantitative variable or continuous variable. Things will be different. So instead of a bar chart that we saw just now, we will need a histogram. Let's do the same thing, insert pivot table, and I'll select mileage and mileage again. So for each mileage at failure, we want to know how many cars failed at that mileage. So some will not do. So what you can do is, if you click here, and you can change the value field to count. So count will tell you how many cars, and that's what we are interested in. Because mileage is continuous, so you end up with too many fields. So what we need to do is we need to group the mileage. So you can be somewhere here under mileage and right click and there is an option called group. So automatically it picks up minimum and maximum. So this is minimum, this is maximum, and let's say you want to group by 10,000 miles. So once you say OK, you have this. You can easily convert this into a histogram. So histogram is a specialized bar chart. So if I insert, in a bar chart generally you have these gaps, but mileage is a continuous variable. There should not be any gap between the two bars. In this option, if you see, there is an option where you do not see any gap. So if you click that, there won't be any gap between the bars. You can make it look different by choosing another way. So this looks much better compared to the earlier one. So this is a histogram, and you can see that this is a right skewed histogram because the tail is longer on the right side. Suppose you have these three data points. Now average is also represented by x bar, will be 2 plus 1 plus 6 divided by 3 because we have 3 data points. So this is 9 divided by 3 is 3. So average is 3. Median is the middlemost value. If you have a data set like 2, 1, 6, to find the median, you have to first put them in order. So 1, 2, and 6. So 2 is in the middle, so that is the median. Now one advantage of median is that it is not affected by extreme values. So for example, instead of 6, if this was 6,000, still median is 2. It is not affected by the highest or lowest value. It is more stable. And especially when you have histograms which are skewed to the left or to the right, in those situations median is a better measure of location. So compared to mean, so mean is affected by every value because you can see in the calculation we have used everything. So instead of 6, if you have 6,000, your average will be very, very high. Let me take one example from garment industry where you have size of certain cloth, and based on how many you are able to sell, you make histogram for that data, and the histogram looks like this. Suppose this is like 5.5 size and this is 6.5. Now if you want to make a decision on how many you should make, and if you depend on average or median, your average or median will be in the middle, about somewhere here. So if you make lot of clothes with the size 6, because that's the average, demand for that is very, very small. They will not sell. So median and average do not work in this situation. What you need is, you want to figure out what is the highest frequency. Like in this case you have two high frequencies. So mode captures that. Mode is the most frequently occurring value. In fact, this histogram is bimodal because there are two modes. Measures of location like mean, median, mode, they give us some information about the data, but not everything. Like in a histogram, for example, I have told earlier that you have to look for location, spread, and also shape. So that gives you a complete picture. If you only look at location, you will not get a complete picture of the data. You only get a partial picture. You may not know how much variability exists. So for example, if there is a person whose head is in the oven and legs are in freezer, and somebody calculates average temperature, they may say that the average temperature is normal. So that person should feel normal. Unless we also capture spread, we do not get the real picture, like how much variability in temperature exists. So to capture spread, again there are several measures. So one of the easiest way to capture spread or variability is to calculate range, maximum minus minimum. So for example, data set 1, both maximum and minimum are 5, so range equals 0. You can see that there is less variation. Data set 2, maximum is 9, minimum is 1, so 9 minus 1 is 8, so range is 8. Third data set, Again 9 and 1. So here also range is 8. One good thing about range is it is simple, maximum minus minimum. But disadvantage of range is that it only depends on maximum and minimum. It doesn't care what happens in between. So for example, third data set obviously is more variable compared to second data set. But range says that range is 8 in both cases. So it has its limitations only because it does not take into account all the values. For this data set, it doesn't care what happens in between. Standard deviation is something that makes use of each and every data point. So let me first explain to you how to do this calculation. So some variable, random variable x, which takes values like, and this is in centimeters, some dimension. Now to calculate standard deviation, we create another column, x minus x bar whole square. So x bar is, you add all these values, so 2 plus 1 is 3, plus 3 is 6, plus 2 8, 8 divided by 4, 1, 2, 3, 4 is 2 centimeters. So once we add this, we get 2. Now standard deviation, which is represented by small letter s, is calculated as square root of this number we just now got, 2, divided by sample size minus 1. So you have 1, 2, 3, 4, so 4 minus 1, which is 2 by 3 within square root. So this should give you about 0.82 centimeters. Now let's create a data which is more variable. So you calculate x bar, which comes to 5 centimeters. So you can see that there is more variation in this data set compared to the first one, and standard deviation also comes out to be higher compared to this one. More variation, higher will be your standard deviation. Less variation in the data, lower will be your standard deviation. If all your data points are same, your standard deviation will be 0. For calculating standard deviation, what we did was square root of, we did x minus x bar whole square, and we use that second column by adding them. So for adding, we have a symbol like this. This means add everything in that column. And then we divided this by n minus 1. So that's the formula for standard deviation, which is this. Now on the left side, you have another formula. So standard deviation is also represented by this symbol sigma. And this is the standard deviation for the population. So this formula is for the population, and this formula is for the sample. In population, we are dividing by capital N. When you are doing any study, or anybody doing any study, you will never come across a situation where you will have sufficient resources, sufficient people, or sufficient time to collect data for the entire population. Generally, we depend on the sample. So this is only for theoretical purpose. We never use this. We always use this formula for the calculation. Now one more thing, for population and sample, you have this standard deviation. There's another term called variance, and variance is square of the standard deviation. So if you have variance and you want to calculate standard deviation, you can simply take square root. Or if you have a standard deviation and you want to calculate variance, then you simply square. One other thing you can remember, for example, if your dimension is in centimeters, then unit for the standard deviation will be centimeter, but unit for variance will be centimeter square. So because standard deviation has same unit as the original data, this is most commonly used. In fact, for capturing variability in the data throughout the world, standard deviation is almost like a standard for capturing variability. That's why you have this name, standard deviation. It is difficult to sit with a calculator and enter all these 1000 plus data points and do a calculation for average or median or standard deviation. It will be very, very time consuming, and if you make a small error you have to start over all over again. It is much easier to use Excel function to do these calculations. So one thing you can remember is whenever you are using any ready-made function in Excel, you always start with equal sign. And if you want to calculate average for, let's say, material cost, so simply type average, and Excel will give you these options. So if you type average, and then it will ask, you start the bracket, it will ask for data. So then click on the column in which you are interested. You can type F:(F) also if you know where your data is, or you select column. So please note, I did not click on material cost. I clicked on F to select entire column, and then you close the bracket and hit enter. So that's the average. So this is the average material cost for all these failures, car failures. Now if you want to calculate median, so same thing, equals median, and then start a bracket, select the entire column and hit enter, you get median. If you want to calculate mode, type mode, select the data and hit enter, you get mode. If you want to calculate standard deviation, so the function name is std for standard, std and then ev. So you start the bracket, select the column, close the bracket and hit enter, you get standard deviation. So this way you can do all the calculations very easily. If you simply click on column F, and if you look at this bottom here, you can see some of the summary measures are already indicated. Like it says average is 179.39, count is so much, minimum is 0, maximum is 3,800 something, and the total cost, material cost, is $291,000 and slightly more than that. In fact, in Excel you can also right click and choose what are the things you want to display, or you can take them out. For example, if you do not want average to be displayed there, you can take them out. Similarly, if you select two columns, that will give you total cost, total labor cost and material cost. Population is every possible observation and sample is a subset, but also it is a representative subset. It cannot be any sample, but it has to be a proper sample. So data is obtained using samples because we seldom know the entire population because of several reasons. We don't have that much money or time or resources to conduct or collect data on each and every item in the population. Descriptive statistics apply to any distribution. You can do it for sample or for the population. But population statistics, although they are desired, they are not available. There is a term called sample statistics. So sample statistics are the numerical measures we get from the sample, like sample mean. This is a sample statistic, sample variance, or sample standard deviation, or sample size, or it could be percentage or proportion, things like that. And then there is a term called population parameters. So population parameters are indicated by Greek alphabets. So this symbol here is mu, and it means population mean. Sigma square we have seen is population variance, and so on. So never mix them up. There is nothing called sample parameters. There is nothing called population statistics. You always have population parameter and sample statistics. So earlier I mentioned that when we collect sample from the population, it has to be a representative sample. To get a representative or good sample, there are several sampling methods that are available. There is a method called census. Like most of the countries, they do 100% data collection in terms of like how many people live in a particular country. That is like 100% inspection. But 100% inspection generally is not 100% accurate, because there could be some people who are traveling, or they may have gone outside the country for whatever reason. It's difficult to get and also very expensive to get accurate data whenever we do 100% census. There are sampling methods that are based on judgment. Many times there are people who have a lot of technical knowledge or experience in certain area. For example, they want to select a right candidate for a job, and they may take an interview, and based on experience and technical knowledge they may ask questions and judge how that person will perform in that role. You have like basketball coaches, they look at several potential players and then they see something in some of them and they feel that these players might do very well in future. So this is like non-statistical method, but there are some statistical methods also like simple random sampling, stratified and cluster. So when we go for sampling, we have to also consider like how much sample size we should go for and how much error we can tolerate, because sample means you only know part of information about the population. So if out of 10,000, suppose that's the population, you take a sample of only 1,000, so still there are 9,000 items on which you have no idea. You only know these 1,000, so 9,000 is still unknown. We cannot say that just based on 1,000 we will be always be right when we talk about the population, because our prediction could go wrong also, our estimation could go wrong because we have like 9,000 unknowns. So obviously there will be some sampling error, and a good sampling method will ensure that sampling error is low. So one of the most commonly used methods is simple random sampling. One example is given here. To estimate the average height of the class, select 10 students at random. So if there is a class of let's say 50 students and you want to predict what is the average height of those 50 students, so you can randomly select 10 students and based on that you can make an estimate. So one feature of simple random sampling is that each item has equal chance of being selected. So there is a function called, let's say we want a random number between 1 and 50, RAN. So there is an option called random between, and then I can say between 1 comma 50 and then close the bracket, and then if you drag this you get 10 random numbers. So as the name indicates, it is still a random sampling but it is systematic. So one example is, I ask every 10th person their opinion on the state of economy. You start walking maybe a university and then every 10th person you meet, you ask and get that data. So that will be systematic because you are using a systematic approach every 10th. You are not going by like sometimes third one, then 10th one or the 5th one and so on. The meaning of stratified is that we divide the population of interest into different strata or different groups or different categories. So one example is given here. To estimate average income of people in US, break the population of US into levels of education. So there is one group with no high school, and then you have high school, college degree and some college. And then sample randomly within each group. So we select some people from this, some people from this. So this way we get our sample. It is called stratified random sampling. Now stratified random sampling is needed sometimes because if we do simple random sampling, it may happen just by pure chance that our sample does not include anything from this group. It can purely happen by randomness. So obviously our sample will not be representative. So if we get information from each possible group, our data becomes more representative. Another method is time series or subgroup. Like certain things happen with time, like manufacturing. In the morning shift, suppose it starts at 8. So first item is produced at 8 a.m. So you collect data on that, and then maybe 9 a.m. every 1 hour you get data. So that is time series or subgroup sampling. So that will indicate like with time if things are moving properly or not. If there is more rejection, for example at 9 a.m., then you may take some action. You can stop the machine if the variability has increased and make sure that everything is right. Maybe the machine was like heated up and it was not giving proper output. So you may stop it and then restart after correcting the problem. When that type of data is collected, that is called time series or subgroup sampling. So we have seen so far different ways for summarizing data, like in tables or graphs or in numbers. We also looked at the overall process, like how statistical inference works, like starting with population, taking a sample, getting data, doing analysis, getting results and applying it back to the population, which is called statistical inference. And one important thing is when we take a sample, we have to get a representative sample, and to get a proper sample or representative sample, there are so many different statistical sampling methods which are available. We looked at different methods. In fact, these are not all possible ways a sampling can be done. There are several other methods like cluster sampling and so on. But these give an idea that in different situations we may have to go for different type of sampling to get a representative sample.